Signal Hounds talking RF, and today we're talking about and demoing the specifications and differences between the SM200B and the SM200C.
Hello and welcome to Talking RF. Tom here, president of Signal Hound, and today I'll be talking about the specifications and differences between the SM200B and the SM200C. I'll be demonstrating the interface to spike and the streaming bandwidth feature using a VSG25A signal generator and both the SM200B and the SM200C spectrum analyzers. The SM200 series line of products are high-performance 20 gigahertz spectrum analyzers and monitoring receivers that have 110 dB of dynamic range and a 1 terahertz per second sweep speed. The biggest hardware difference between the two is that the SM200C comes with a 10 gigabit Ethernet SFP Plus port, enabling fast communications over long distances to your PC using fiber optic cable. With all three of these products connected, let's dig in. I'll be generating signals using the VSG25. I chose the VSG25 because it can give me reliably about 100 megabits or megahertz of bandwidth out. And I need to be able to show one of the key differences with the two platforms. I've got an SM200C, and I mentioned the SM200C major difference hardware-wise is a SFP Plus port for interfacing to the PC. I'm also using a QNAP 10 gigabit Ethernet to Thunderbolt adapter to interface to the PC. So that's a big difference with the SM200C. The SM200B is a USB connection. So I've got a USB interface to my laptop with the SM200B. The big difference between, what's the difference between these two? There is the streaming bandwidth. And we'll talk about that during the demo and focus in on what I mean by streaming bandwidth. But the SM200C is capable of streaming 160 megahertz of IQ bandwidth constantly, continuously to your PC. That's why it needs the 10 gigabit interface, the 10 gig Ethernet interface. The SM200B, however, can only stream 40 megahertz of instantaneous bandwidth continuously to the PC. And we'll talk about what that actually means in Spike, what it means from capturing and taking measurements with the two devices, as well as what it means in recording. So let's take a look at the software. So I've got the VSG25, and I loaded a preset that is going to send a signal. It's basically a multi-tone signal that's 1,001 tones that are spaced about 100 kilohertz apart. That gives me a little over 100 megahertz of instantaneous bandwidth. I'll go ahead and launch Spike, and I'll connect to the SM200B. And I'll be switching between these two versions of Spike, between the SM200B and the SM200C throughout this demo. So we were centered at 1 gigahertz. I'll go ahead and center this at 1 gigahertz. And we're looking at 100 megahertz of bandwidth. So we'll go ahead and span this out to 125 megahertz. And then I'll just make it as large as possible. So here you can see the spectrum, the FFT plot of what we're seeing in terms of the signal that was generated with the VSG25. So I'm going to launch another version of Spike and connect to the SM200C. Okay, as it's connecting to the SM200C, I'll do the same setup. It's centered at 1 gigahertz, span of 125 megahertz. And what you can see is that the FFT plot is the same between the two. So we know that the SM200B, which is this device, has a 40 megahertz streaming bandwidth. What's the catch? Why am I able to look at this full 100 megahertz of bandwidth and the FFT plot looks the same as the SM200C? Note the SM200C with 160 megahertz of streaming bandwidth. What's the deal there? And the deal there is that the SM200B has 160 megahertz of bandwidth. Its instrument bandwidth of that device is 160, but it windows for 2 seconds, and it will display a 2-second window of FFT plot. So because of the refresh rates on the laptop, we're able to actually show you this in roughly real time. I can even move to the real-time mode, analysis mode, and you can see this. We can show you those plots because we're taking that full 160 megahertz of bandwidth, we're moving it over at 40 megahertz, we're moving it over the USB-C and just displaying it, and we can't really see the difference in that display at all. I can do the same with the SM200C. Change to real-time analysis mode, and you see the same thing. So where does the difference actually matter? And the difference actually matters anytime you need 160 megahertz or full bandwidth streaming. If you need full bandwidth streaming because you've written your own applications, well, then you would care. You would want to look at an SM200C model. If you were just taking measurements and you didn't mind that you were strapped 3 feet away from your PC, then a SM200B model might actually be the preferred model for you. You can save a little money with the SM200B model. If you need to remotely locate the SM from the PC up to 10 kilometers, well, then you want to look at an SM200C again, because with the fiber optic cable and the correct transceivers, you can be up to 10 kilometers away from the PC that's actually running Spike and showing the application and showing the FFT plots. Okay. And I can show you that by going to the IQ recorder, and you immediately see on the SM200B, which I have up, that I've been limited now to about 40 megahertz of bandwidth, and you can actually start to see that the FFT plot is different. What does this look like? Well, this is the 100 or the 1001 tones that we had spaced over 100 megahertz, but I'm only looking at 40 megahertz of that plot with the SM200B. If I exit out of that and go to the SM200C, and you can look at the IQ recorder, and here we're actually looking at the full 160 megahertz of bandwidth in that IQ and that FFT plot. So those are the two basic differences between the two. The SFP Plus port for 10 gigabit Ethernet connectivity allows you a much fatter pipe for getting data from the unit to the PC, and you can do the full streaming instrument bandwidth of 160 megahertz. The SM200B, however, we can do 2-second snapshots at a full bandwidth 160 megahertz, up to 2-second snapshots. And then we are going to stream that over, from a streaming bandwidth perspective, we're only able to stream 40 megahertz of bandwidth over USB. And from a measurement perspective, when you're just sampling data and measuring it and displaying the plots, you see that they're both basically the same. We can take the same measurements with both devices. So those are the basic differences between the SM200B and C, and they're common across the entire SM product line. If you have any questions about the SM200 series line of products, the VSG25A, or any of the features and demos that we went through, leave them in the comment section below. Like, follow, and subscribe for more Signal Hound and RF content.